Hi everyone, welcome back to our channel Vedangas. This is Amit, accompanied with my co-partner Sumit. So guys, before going to the video, please subscribe to our channel and hit the bell icon for the latest updates. So let's start the video. Hi everyone, in this video we are going to learn about the statistical error and approximation, and also the classification and the tabulation of data and frequency distribution. So let's start. So now coming to the statistical error and its approximation, this is an unknown character which shows the difference between the retained value and the true value. It shows the difference between retained value and true value, right? It is also immediately associated with accuracy. It shows the correct result, the quality or a state of being correct. So this statistical shows a correct accuracy, since this accuracy is also mean to the inverse of total errors. Okay, and the statistical error are one of the special kind of errors in a class of error which are known as random errors. We can also say that it is a random error. The statistical error is a random error. The errors has some types in statistics. There are mainly two types of errors in statistics, that is type 1 and type 2. The type 1 error refer to the elimination of true null theories. It shows all true null theories in type 1 error, and in type 2 it shows all non-elimination of the false null hypotheses or theories. A type 1 error is also known as a false positive, and it occurs when a researcher incorrectly rejects a true null hypothesis. This means that your report, that your findings are significant when in fact they have occurred by chance. Okay, but coming to the type 2 error, it is a statistical term referring to the acceptance or non-rejection, acceptance of false null hypothesis. It is used within the context of hypothesis testing. A type 2 error produces a false negative, also known as the error of omission. The type 2 error is also known as error of omission. Now coming to the sources of errors, from where the errors is occurred. In this, the second axis distinguishes 5 fundamental sources of statistical error, that is sampling, measurement, estimation, hypothesis, and testing, and also reporting. So these all are the several distinguishes fundamental sources of statistical error, from where the error is occurred, the source of errors, right? And also the main sources of error are of two types, that is based errors and unbased errors. The based error refers to the deviation that are not due to chance alone. The simplest example occurs with a measuring devices that is improperly calibrated so that it is consistently overestimates or underestimates the measurement by X units. So even the suspension of basis can render judgment that a study is invalid. So that is a based error. It is also known as systematic error. Now the unbased error, it is a sample estimate of a population parameter whose sampling distribution has a mean that is equal to the parameter being estimated. To get an unbased estimate of the population variance, the researcher needs to divide the sum of squared deviations by 1 less than the sample size. Okay, so this is about the based error and unbased error. Now coming to the classification and tabulation of data, how the data is classified and tabulated. So in this, the process of arranging the data into different categories on the basis of nature, behavior, or common characteristics, that is called as classification. And tabulation is the data which is arranged in rows and columns in a systematic way, that is tabulation. So the tabulation of data is a systematic and logical presentation of numeric data in rows and columns, which facilitates the comparison and statistical analysis. And also we can say the method of placing or which is organized data in a tabular form is called as tabulation. And this tabulation has some major objectives. The major objectives of tabulations are to simplify the complex data. That means it reduces the bulk of information, which is the raw data is simply in a simplified and meaningful form so that it could be easily by a common man in less time. So it has a simplified complex data. Next one, it brings out the essential features of data. The tabulation brings out essential features of data. It brings out the chief characteristics of data, and also it presents the facts clearly and precisely without textual explanation. So it also make easy explanation. So it brings out the essential features of data. And also third one, it facilitates the comparison. The presentation of the data in rows and columns is helpful in simultaneous detailed comparison on the basis of several parameters. So this tabulation helps in facilitating the comparison between the rows and columns. And next, it also facilitates the statistical analysis. Tabulation facilitates statistical analysis, in which the table serves as the best source of organized data for further statistical analysis. And the task of computing average dispersion, correlation, etc. and the task of computing average, dispersion, correlation, etc. becomes easier if the data is presented in the form of tables, so that the tabulation is helpful to facilitate the statistical analysis. And the last one is saving of space. A table which is present a facts in a better way than the textual form. The table helps to present everything in a better way than the textual form. It also saves the space without sacrificing the quality and quantity of the data. So this is all about the objectives of tabulation. Now next one, while coming to the frequency distribution of statistics. So the frequency distribution is the next step after the completion of data collection. It is to design or organize the data in a meaningful form so that a trend, if any, emerging out of the data can be seen easily. So one of the common method of organizing data is to construct frequency distribution. Thus, the frequency distribution is an organized tabulation, graphical representation of the numbers of individuals in each category on the scales of measurements. And it also allows the researcher to have a glance at the entire data conveniently. It shows whether the observations are high or low, and also whether they are concentrated in one area or spread out across the entire scale. Thus, the frequency distribution presents a picture of how the individual observations are distributed in the measurement scale. So thus the frequency distribution are used in the statistics. The frequency distribution tables, it is a graphing data which is typically in the best way to see the patterns in the data and to look the potential problems. However, some precision is often lost with graphs. Therefore, it is sometimes useful to look at the raw data in a frequency distribution table. For example, suppose that a market researcher asked cell phone user to respond a statement that I am very happy with my cell phone service provider, and the people were asked to respond with 1 is strongly agree, 2 is agree, 3 neither agree nor disagree, 4 disagree, and 5 strongly disagree. So according to this statement, the table here given, that is, so here several types of options are given 1 to 5, that is X, and F, the peoples who are satisfied, who are saying about the cell phone. So here the strongly agree peoples are 2, and 4 peoples is only agree, and 7 peoples are neither agree and nor disagree, and 6 peoples are disagree, and the strongly disagree peoples are 4. So here several types of ratings are given to the phone. So this is all about the frequency distribution table, which shows the data in a particular correct form. So this is all about the statistical errors and classification of classification and tabulation of data, and also the frequency distribution of statistics. So thank you for watching the video.